Hello, everybody. Welcome in. We'll be getting started in a couple minutes here. I just wanted a quick introduction on how the Teams webinar works. At the top of the window, depending on your organization's security policies, you're either going to have access to the chat window, the Q&A window, both, or maybe neither. It really depends on what your O365 admin has set up for you. We can't really have any control over that. So if you're unable to access any of those, please reach out to them. The chat window is just for general comments. You can say hello, use your AI note taker, what have you. And then the Q&A window, near the end of this presentation, I'll be facilitating these questions to the presenters that we have here. So we'll definitely have some time at the end of their presentations to go over these, ask some questions. Definitely make use of it. I'll make a little test post here just to see that you can react to it. You can post a comment, etc. And maybe try posting a comment too, just get familiar with the resources. And I think we are ready to go. And I'm Vlad, Developer Relations Manager at Acumatica. I am joined today by three wonderful Developer All-Stars. We have Paul Gilfoy from PriceKubecka, Robert Waite from Net at Work, and Marco Villaseñor from Interastar. And starting us off will be Paul Gilfoy. I'm going to hop off camera here. Paul, take it away.
Awesome. Thank you, everybody. As you heard, I am Paul Gilfoy. I'm from PriceKubecka. And I wanted to hit right from the get-go AI hallucinations. I work with a lot of companies, and without question, the largest apprehension I hear when it comes to adopting AIs has to do with, how do I know they're not going to get something wrong? What about incorrect information? So let me tell you a little story. I've been working with agentic workflows for quite some time. I posted this on my LinkedIn a couple months ago, and here was the fundamental question. In this agentic workflow, I have two AIs, one that interacts with the user. That AI that interacts with the user is very empathetic and charming, like yours truly. And that AI can understand the user's requests, understand the query, break it down. It can communicate back to the user, hey, we can do these things, we cannot do these things. And it can notify team members when it cannot accomplish a goal. Okay, we're going to call this the customer service AI. Well, this customer service AI, it can go through all of these requests, and then it sends it over to the AI that actually interacts with Acumatica. This AI can create, read, update, delete records in Acumatica. It can pull information. It can maybe update a customer, whatever you need to. It actually gets stuff done. We'll make up a name on the spot, and I'll just call that the IT guy. And so the question I posed to my LinkedIn followers was, of these two AIs, which one do you give more compute resources to? I'll show you. I have a little demo set up. And so this is a laughably simple interface. I took off all the branding for my client on here, and I just have a simple request I'm going to put in. You'll have to humor me. I have a 1-year-old at home, so I'm asking it to create Sesame Street at 123 Sesame Street in New York. The phone number is 555-123-456, and the email will be Big Bird. And over here, I have the U100 data set sitting and waiting as I reload my demo environment. So here's our circumstance. We have our queen bee who receives the user request and then can deploy it to different worker bees according to the need. Make sense? Okay. So if we jump over to our environment, I can see over here, Sesame Street was successfully created. We have the correct address. We have the phone number. We have Big Bird in there. I can even go back to my AI and say, hey, I forgot, I actually need you to also create a contact for Big Bird. And it'll go and deploy, yada, yada, yada. Very wonderful. So the way we fundamentally built this architecture for the client, and again, I cannot illustrate enough. I cannot illustrate enough. I think I've spent maybe 3 work days on this. We have our customer service AI who is interacting with the customer. Sometimes those are called retrieval AIs, but regardless, customer service. And it deploys the work to these smaller AIs that are trained on one narrow function within Acumatica. And so I have my customer AI that knows how to pull customer records, how to update a customer if needed. And I have our contacts and sales orders. You know, we could add inventory to this, and there's lots of other things. Let me jump back over to the demo. Actually, I'm curious to find out if the contact was created. Let's find out. I think it gave an error. That's all right. So fundamentally, I want us to think about this. We have a chat interface where text goes in and it accomplishes a goal within Acumatica. This year in the hackathon, one of my team members asked a fundamental question. Why would we ever manually input data into Acumatica? I think Tim Rodman posted, I thought, a hilarious comic on his LinkedIn. He said, my car drove me to work today, and now I need to manually input all of these invoices. It's laughable. We have so many resources. So let's go back to the fundamental question. We have this multi-tier AI structure. Who gets more compute? What do you think, dear listener? Does the customer service agent get more compute so that it can break down the tasks into subtasks and give them out one by one? Or does the IT guy get all the compute so it knows how to break things down? This is actually, I think, a secret within the AI world. It doesn't actually matter. I'll point out this paper to all the nerds in the room. This is learning to reason via mixture of thoughts for logical reasoning. I will be posting this in the chat. I have a bunch of AI resources if people want to dive in deeper. But fundamentally, what this paper ended up finding out is they had a series of 9 billion parameter models, okay? The largest AI models on the market right now are in the realm of trillion parameter models. When this paper was published, I believe the largest model at the time was something like 400 billion, okay? 9 billion, 400 billion. Let me illustrate the 9 real quick. I could run that on my machine right now. I could run probably 3 copies of that on my machine. Very small models, okay? Why are you highlighting this, Paul? All right, because what they found out is when they compared high-end reasoning models to these smaller 9 billion parameters, of course, the higher ones won. But when 3 separate models trained in their own unique domains teamed up and worked together, they were actually able to outperform the higher tier models. So this is sometimes called a multi-tier architecture. We'll go back to the original concern. Why do people not adopt AI? Because they are concerned that they are not going to get the correct information out of them. But when you can stack smaller models together, train them on unique domain knowledge that they will know, you actually end up with significantly better outcomes. Does that make sense, everybody? So this is just one architecture. I'm going to jump through a couple more. This is another common one you'll see. It's sometimes called agentic RAG. RAG stands for Retrieval Augmented Generation. And in this architecture, we have a large language model that might get the request, create the customer. And it can then go and ask the database or the RAG agent, hey, I'm going to make a customer in Acumatica. How does this company format their customer IDs? What are the most important fields when creating a customer? If anyone's ever seen how many fields there are in Acumatica, there's hundreds of fields. My company, we use maybe a dozen, right? What are the most important things that I can pull out? And you can augment this with retrieval augmented generation. And then you can maybe add a reasoning chain. I'll even mention one more thing just as a side note. To the audience, who do you think writes the best prompts for AIs? Ironically, AIs write the best prompts for other AIs. So a common strategy here is even to add another AI down here that would receive, this is the goal from the user with their query. Format this in the best possible way to get that result. And then it will augment, it'll format the query and send it up to run through the system. All right, makes sense? I'll mention one more, LLM as judge. This is one of the most laughably simple methods for avoiding hallucinations. And it's literally this. You query the large language model, it accomplishes the task, and before sending it back to the user, or maybe before calling into Acumatica, you run it through a judge. That judge gets the query and the result of the first model. And it asks it, do you think this is correct? Or do you think this model hallucinated? And there's been papers that showed this reduced hallucinations by 80 to upward 90, 95% of hallucinations were eliminated just through a 2-tier architecture, not to mention the 3. All right, so listen, these are just basic architectures that are laughably simple to implement. Like I said, the one I showed in the beginning was for a customer that I built over a weekend. I've probably spent 3 days of work time actually creating it. And they can upload an entire Excel sheet. They can send emails to the client and have it create as many customers as they need. All right. The biggest takeaway I want to mention right now for everyone, when we're talking about these AIs, when we're implementing these architectures, when we are using the power of these models to impact our business, I want everybody to treat your data like an asset. We all have our profit and loss statements or your balance sheet, right? Add your data to your asset column. What that might look like, I have 10,000 high quality emails that my customer service team has responded to. You can use those to train a local agent running on my local machine that might augment your customer service team so that instead of manually having to type all of those, they already have 10,000 examples that they could say, maybe you could say something like this. It is a way to augment the users we have to get the best results. What might else that look like? In Acumatica, I have 1,000 customers, and I can guarantee we've spent the time to make sure all 1,000 records are formatted in the way we want. They are perfectly formatted. And so I can run that through a recovery augmented generation to make sure that if I'm creating a record in Acumatica, it is formatted in the same way all the other ones are. In the words of Peter Drucker, what you measure gets managed. Put your data on your asset column because this data is gold. We can use them to completely change how we do business. And I will bring up the question yet again. Why would we ever manually input things into Acumatica when we have these tools at our fingertips? All right. Okay. That is just my basic presentation. I hope this illuminates how easily you can implement these large language models into your business workflow. Mr. Vlad, you are up. Unless actually Marco and Robert, unless you guys want to throw a question.
Yeah, Paul, thank you. Very exciting stuff. Robert, Marco,
I'm
any
going to build off of
thoughts?
that. I'm certainly going to build off of some of the things that you've said there because it certainly falls in line with how we've organized it. I got some prompts prepared, and I have in fact used an LLM to help me refine those prompts to make them better. And to your point, like, well, what's the best tool, or who's going to get that done best? It's an LLM at the end of the day, and certainly going to build off of that concept of like why manually put this in, because I have a automated system to demonstrate as well.
Right.
Cool.
Yeah, and I'm also just going to talk about like all these patterns that you mentioned. So I think it serves as a good wrap up to end the talk with a clear idea of the different patterns that are available. So I think everything complements really nicely. So thank you, Paul.
Nice. Cool. Robert?
Cool. Awesome. Thank you, Paul. Yeah, Robert, go ahead. Show
All
us what you
right.
got.
I'm up next. All right, so I'm going to spare you guys the death by PowerPoint and go right into demonstration and use some of the prompts that I've organized. So let me get my trusty chat prompt in here. So I got this one here organized. I'm just going to fill in the topic. So the topic, there's two main topics that I'm going to cover. One is N8N and another is called Anki. I'm going to put Anki in here and see what we get in here. Okay, so it's a free and open source flashcard application. It uses spaced repetition to improve memory retention. So my topic is accelerated learning and leveraging N8N. So when you learn something, the fact of the matter is if you don't strengthen and revisit that topic, you're going to lose it. It's just human psychology. There's science behind it. There's what's called the Ebbinghaus curve, where it just if you don't repeat or reflect on the information, you're not going to retain it. And this is what Anki really helps out with. So it's a flashcard application. The end result at the end of the day is I've been using this for 5 years, and I thought, hey, maybe I can use AI to create an audio version of these flashcards. So I've accomplished that, and this is the end result. We have an Anki deck in here, and when you go through these cards, I don't know if the audio is coming through here, but as you go through these cards, you can see that it's got a question and answer, and I'm going to show you how I built this to a point where I don't have to manually key this stuff in and build these cards myself. So I could spend a whole hour on the topic of Anki. I'm gonna get on to the next topic here real quick, but that's it in a nutshell. And I would love to have the opportunity to just take a whole hour and just like go over and build this tool from scratch to kind of show you how N8N really shines. I'm going to go ahead and grab that same prompt, and I'm going to plug in the topic of N8N. So N8N stands for Node for Everything. Node Everything Now. It's a low-code, no-code automation tool for connecting apps, APIs, and services. It's very similar to Zapier, Make. There's a couple other ones out there. There's Node-RED. But what really makes N8N shine is the AI agent tool. From what I understand, there is no other tool out there that has really quite done it like N8N has. So what we have in here is I'm able to generate a chatbot. So I got this trigger in here for chat. We're going to demonstrate its use at this point, and this AI agent is here to create an Anki card, Anki cards based on a set of question and answers. I drop those question and answers in here, and this agent goes to town building stuff. So what every one of these AI agents needs is a chat model, and there's several LLM versions out there. You can tie into any one of those. All you need is an API key, and you're off to the races, and you're ready to go. The memory is optional. Generally, this is going to provide the context if you're actually having a chat and you need the LLM to remember what you said previously and what the results are previously. You're going to need memory. There's all sorts of different ways that you can establish memory. This one's set up with just basic RAM memory. You turn the instance off, it forgets everything, and then when you but everything that's in RAM goes. And I have two tools in here. I have one to create an audio file and move to Supabase, and I have the create Anki cards. So these are actually other AI agents that are doing jobs. So Paul had mentioned that you accomplish this stuff through divide and conquer. You get one AI agent to do one thing really well. And then I have this master AI agent in here that actually does the work and calls into these tools. And I just have to give it a definition to the tool. And the difference between this and other services is this is a non-deterministic approach where the AI agent actually decides how it's going to solve the problem, whereas other AI agent type tools and workflows, you got to build the whole prompt, and you got to set a deterministic sort of approach to how you're going to solve the problem. So let's get into the topic of creating deep knowledge about something and deeply learning something. So something that we all on this call, this is a development sort of forum, so we all want to get better and have a deep knowledge of Acumatica development. So you want to start with a prompt like this. Okay, you're assuming that you have no knowledge. And you start by giving the AI agent a role. You are an expert in Acumatica development with deep knowledge of the platform, architecture, customization, and deployment practices. Your task is to create a comprehensive structured learning outline that can be used to develop deep expertise in Acumatica. And here's some details of doing that. So let's see what the result is on this. So essentially what we're doing here is we've just built ourselves a syllabus of and a guide to go through a handful of topics. These are all the various topics that you're going to need to cover if you want to have deep knowledge. You definitely want to kind of follow the T200 or the T courses, the T200 through all of those series. That's an excellent way to get yourself up to speed. And then you could go by chapter too, and just build this knowledge. But one of the key things to using Anki is one of the primary rules is learn first, then memorize. If you try to memorize something without first learning the concept and understanding the concept, you're just wasting your time, and it's just going to be a lot more difficult to get that information to stick in your head. So you could base your whole study, and this you could plug in whatever topic you want to learn. If you want to learn N8N, you can specify that as a topic and use this as a syllabus. You can use actual reference material for that sort of stuff. So let's go into the next prompt here. All right, this is going to build the questions at this point. So I'm going to drop this in here. And I'm going to fill out that, that topic in here. I'm just going to say, I'm just going to put the fundamentals. I mean, you can't get enough fundamentals, in my opinion, and it's always the fundamentals and really getting a solid understanding of that. That's what really makes you a very efficient programmer, because the vast majority of anything, 80% of everything that you're going to do, it's all fundamentals. But I'm going to launch that prompt there. Do also notice that I'm giving in an example here as well, and I want the format to be in this format for consistency. And look what we get. We get a whole handful of questions at this point. I can also add in, like, can you give me more questions and those sorts of things. And all I need at the end of the day is to take this list of questions and plug it into that N8N prompt. And I am going to apologize ahead of time if there is an error that happens over here on this side there. All right, why isn't this plugging in here? Oh, there we go. All right, here's the questions. All right, this is all going to work at this point. You can see that the chat model is getting engaged. It's parsing all of these questions out, and we're going to go over that prompt as well and where that prompt resides within this control. And we're going to see cards being created over here on the side, so you can actually see it working. And what's really interesting about this too is you see it work different ways. If you go into the nitty-gritty of this stuff, you can see all of this stuff, but you see that we've just created a 40 audio files altogether. So there's 20 questions total. We want a question file and we want a answer file on it. This is working away here, but I can go to show you that this stuff is now, I have this stuff being stored into a Supabase instance. And here's all those questions. And I did want to show this empty before I started, but I missed that. But we could see here we have audio files created. So we got the answers there, and we have the questions over here. Everything's got a distinct file now at this point. And then to complement this, I stage all of this stuff. Let me do there we go. We got our questions in here. This is where that information gets staged, and this is what that first agent is actually doing. Is it's plugging this information into that storage file, it's creating this table in here, and it's preparing the statements that need to be fired off and sent to the Anki Connect program. So let's go back to this here, and sure enough, I do have some errors in here. I am troubleshooting this at the point, but I have some mechanisms where I can kind of give it a bump and hobble it along a little bit. But we could see that this agent is sending stuff to Supabase, and we have an HTTP request that's being sent to my local computer instance that's hosting what's called the Anki Connect API, and it allows me to create cards programmatically. And that's what this N8N service really digs into to facilitate at the end of the day. So how does this all work? Let's go into one of these prompts here, and at the center of each AI agent that you build is a prompt. So the prompt is, you are a study assistant that creates flashcards for a learning application called Anki. You will be provided with a deck name and a list of one or more question answer pairs. Your task is, if the deck name is specified, use it. Otherwise, just default it to test. Audio generation for each question answer pair, use the create audio tool. So this is where you grant the non-deterministic approach, and you just let the AI or the AI service to figure out the logistics of using the tools. You just define the tools. So use the AI audio tool to generate an MP3 audio file for the question and answer. For each audio file, ensure each audio file has a unique file name with a MP3 extension. Card creation, once the audio files are saved to Supabase, then use the create Anki card tool to create the Anki card flashcard for each of the pairs. Include both the cleaned So one of the things that I hit in terms of building this too is there's a certain degree of data scrubbing that you need. There's like special characters that will just blow up your JSON string, your JSON body if you get them inserted. So I have some prompting in here to actually do some of that data scrubbing task in there. So and then finally we have the input from the chat input that it uses to process. And
Awesome.
how am I doing for time, Vlad?
I think we're coming right up to time. So if there's anything
Okay.
you want to summarize, otherwise, this is really great. This is awesome.
I mean, I could go deep into it, and one of the things that I could do too is I could open this up as a community project, help others study the Acumatica framework and use this as a tool to help reinforce that knowledge. And what's probably going to happen is I'm going to write a console application that's going to take care of this. So if we assess the error detail in there, there's some sort of socket issue that happens sometimes, but not all the time. And it's been a pain right now, but I got a plan to solve it. And by the time it gets up into a GitHub repository, it's going to be working.
Cool. Yeah. Oh, Marco, any thoughts on Robert's learning flashcards for Acumatica? I think it's great, especially if you're a new developer.
Yeah, I'm actually looking forward to that, having that tool to start building my own notes. I actually started using Anki by Robert's recommendation. And I need to get back to that because I haven't used it for a while. But yeah, being able to build the decks automatically with a tool like this, it's really, really useful.
Yeah. One of the things that I want to do too is I want to build off of what Paul had demonstrated in terms of using LLM as judge. Mm-hmm. One of the things that I'm concerned about is just knowing and understanding AI. I don't want hallucinations to be in my cards and reinforcing information that's not actually true. So I can build another agent that could do a second round on that staging data and just verify and validate, hey, is this actually true? And use a LLM as judge to validate, help me validate the information. Mm-hmm. But you should be able to, at the end of the day, like determine is this actually, because you want to do this when you freshly learned the material. You don't want to use this as a tool to actually learn it. Learn first, memorize second. And that's an important concept when you're using a tool like this. And you just got to remember the fact that memory is going to slip. That stuff's not going to stay in your memory indefinitely. And if you don't use a tool like this, you're going to forget it.
Yes. Yeah. Good point. And Paul, any thoughts?
Yeah, NAN is a phenomenal tool, especially if you're trying to plug and play a lot of things together. And especially it's very low code, no code. Is that correct, Robert? So I would say just about anyone.
Anyone can get into this. This is low code, no code. I mean, you still kind of need to think of a problem through a developer's type of minds, but it's not a prerequisite. Being a developer certainly will help you break down the topics and stuff like that, because you want to organize this in a way where you get smaller agents together to do one thing really well. Yeah. You don't want to have a single agent do all sorts of different things.
Yeah, exactly.
Awesome. Fantastic. All righty. Best for last. Marco, take it away.
Thanks. So I'm gonna take from what we just saw, different ideas, try to wrap them up into concepts so everyone can take this information and build their own projects with AI tools. So basically what I'm going to talk about are agentic systems. So what are agentic systems and AI workflows. And actually, we just saw and talked about them a little bit with Paul and Robert. And I'll give a little ideas and pointers on when to use which, right? So starting from the most simple and basic are workflows, right? So AI workflows are predetermined code paths. So it's basically what every one of us starts doing when we start playing with AI. A very good example is what you just saw with Robert. So you want to use AI LLMs to help you with a process. So you build that code path, that process, you plug in your LLMs, other tools, and you build your workflow. So basically you automate it with LLMs, right? So you have fixed steps, it's predictable, it's consistent, you just start using it, right? On the other side of the spectrum, we have agents, and that what that we understand with agents are LLMs that are connected to dynamically control their process, so they can make decisions based on the instructions we gave them, the prompts we gave them, and basically this gives us more flexibility. It's basically, instead of having the predefined steps, is to have LLMs or other AI engine basically build the flow or the steps for us within some restrictions, obviously. And so how can we leverage that? How can we decide when to use which, or what, let's say, what patterns we have available for that, right? And so on the workflow side of things, we have some really useful patterns, right? And some of this we can see are really simple, we can understand. The simplest one of those is prompt chaining, right? So it's we saw that with Paul, what he mentioned, like have LLMs build the prompt and have that as an output for the next step. And so that is a useful block, like constructing block we can use to have a better automation, right? Then we have routing, and this is basically when we have a simple workflow, we have like business rules that tells the system or the flow what to do, but we can build that in also in agents, right? So they make that decision. And finally, we have parallelization, where we can have basically when we have a lot of work to do, we can split that into smaller chunks and have that work be done by different processes at the same time, so it finishes faster. And on the other hand, for agent patterns, like the most common we see is the orchestrator, and that's when we have this, and I'm going to talk about this a little bit later about the different parts in an agentic system, but basically we have an agent or a part of the system that looks at what needs to be done, and it decides what we need to do and who is like the best element to do it, or the best agent, or the best system, or the best tool, right? So it's not only splitting the processes, but it's delegating depending on what needs to be done. And at the end part of that, it takes all the inputs and the different things that has been done, and it generates like the end result. So it orchestrates that part, right? It tells which system or which agent needs to do what, and then it takes all the different pieces together and brings them back together into a final end product. And the other pattern that we have is the evaluator optimizer. Paul you mentioned that as the LLM as a judge, basically is taking that output, and it could be from an orchestrator, it could be from a straightforward workflow that has run in parallel, or whatever other input we have from a process, and it evaluates that output. So it decides even if it needs to work on it again, if it's a valid or not, if it derives to an error state, or if it continues working, right? So as I mentioned, these are all patterns that we can use as building blocks. But basically, this allows us to generate bigger and more complex systems. So having talked about those building blocks, those patterns, then what is an agentic architecture? And basically that architecture is LLMs plus tools plus memory. So it's a model that generates its queries, its prompts, what it needs to do, decides what it needs to do, and adapts dynamically, right? And it's simple to talk about it like that, but basically it needs to, if we talk about like the tasks or the roles that it need to do, that an agentic architecture does, it plans, it acts, it reflects if we add that evaluator pattern, and it needs memory, right? It needs to keep context. All the different pieces are working together and correctly. So that looks like this, right? So we have putting all the patterns together. We have a goal manager. That's the one that decides like what's the goal, what's the objective, or the what we need to do. The planner that's going to split the task, the executor that could be different agents, right? As we talked about it. So we have different agents working together. We have memory to keep that context, and then we have reflection or critique on the module so we can validate that output, right? And one important thing to consider here is that the idea is that we don't have one single agent doing everything. These are all different pieces. Even some of these could be initially defined or static. It doesn't need to be everything built with LLMs, but we can leverage LLMs for this. And the idea is to have simple agents, very good doing one specific task, but be able to connect them in a more powerful architecture in a system. So going a little back, the different things, when to choose which, or what's the difference between doing it with a workflow or with an agent? Well, as we saw, right, workflow is fixed. It has its coded logic. It's highly predictable, and it's very fast for simple tasks. So it's repetitive, really just processes. So in an architecture, in a system, it makes sense to do it as a workflow when it's highly repetitive. And agents give us all that other flexibility, right? So it's dynamic. We can leverage LLMs to have a broader scope of what it can do and decide. And especially that's very useful for complex inputs. If it's like, for example, natural language, obviously, right? Like if the input's from a user or from a document, excuse me. It's less predictable because it's probabilistic, but and it has a higher latency, right? It's slower, but it has more capability of what it can call and what it can do, right? So the use case is for something more complex, or you need to adapt. So let's do some simple examples. For workflows, we can talk about things like order processing, right? We need to just parse a document, get information from it, approve a document, if an invoice, for example, if it matches certain criteria, a tax script. So we can have LLMs in there, but it's a simple process, repeatable process, right? And when we use agents or even an agentic system for things that are complex, that are changing, that have a broad range of things that we need to consider. And the most common example we see, and you can identify with that, is customer support. Like all the different people have different ways to express their needs, their problems, even if it's the same problem, right? We need to be able to understand that. And they can have different things that change a little bit. So one problem could be fixed with just one thing, but for another one, perhaps we need to send an email or read something. So there's could be more complexity and more steps involved. Or even for intelligent data entry, if there's not something that just a simple form, but we need to parse and ask for more information, then it makes sense to start using agents, right? But I just wanted to give one simple advice, and it's always for systems, start simple and ramp up to agents when workflows can handle complexity. So even if it sounds like something really useful and really interesting to use, always start with workflows. And only when you start hitting that limit or a use case that you can cover with workflows, then it makes sense to jump to agents. So you don't add complexity when it's not needed. Excuse me again, sorry.
Thank you, Marco.
So
any last minute thoughts you wanted to summarize?
Yeah, I just wanted to do some quick wrap up. This is just a quick example that I wanted to talk about of a conversational assistant that we can build with an agentic system. And the same example is basically have a front end that receives the customer's input, and in the back end you have different small agents specialized in different tasks. So that assistant takes the data, parses the input, and says, "Hey, okay, I need to look at customer invoices. I need to collect that data." Then another agent knows how to use that data to give a simple response, like to consolidate that data, and the front-end agent is able to provide that information back, right? So this is a real use case scenario of agentic systems. So let me just quickly wrap up. So this is basically workflows, simple, predictable, agents, flexible and dynamic, and start building from simple solutions, your complexity up as your system needs it.
Awesome. Thank you, Marco. Starting with a workflow, and then once it's ready, maybe consider doing an AI agent, and then the pros and cons of each one. Paul, Robert, your thoughts?
Yeah, that's one of my favorite quotes is the most common error of a smart engineer is to automate a process that should have never existed. And if any nerd is on the call, you guys know the temptation to automate something, to work on it really hard, and then to hear from your stakeholders, "Oh, use cases has changed. Throw out everything you built."
Yeah. Yeah, and this is one of the reasons I like N8N is it's just short and simple, short and sweet agents, and being able to pull them together is going to be a lot easier than writing code to make some of this stuff happen at the end of the day.
That's right. Yeah, I think, when AI was first released, it's like, whoa, this is really, it could generate pictures and, give some quotes back. But I think it definitely made programming and technical tasks have like a lower skill floor required, and it makes it more accessible. Like, I wouldn't say I'm a developer, but I've definitely used AI to help me either automate tasks, make some documentation easier to understand, or just really help me like organize my thinking. So if you're not playing around with AI because it looks daunting, don't worry. Just come up with a few prompts, take it easy, and definitely take advantage of it. It's a wonderful tool. It's like from typewriters to computers. Like it's that big of a jump.
Vlad, I'd love to jump in here. There's a question actually in the Q&A that I wanted to actually cover in my presentation, and since we have a little time here, I can mention it. The question has to do fundamentally with security. Sean Hayes, he says, Given that we have input-sensitive business information, such as company-specific questions, concerns, or requests into a large language model, how do we ensure that the data is protected so that, et cetera, et cetera? Okay. When choosing what model to use, a lot of these models, it's sending it to a nebulous cloud run on someone else's machines that you can never really verify. What Marco, Robert, and I have illustrated in these examples is you can actually use smaller models, chain them together, and have marvelous results with that. That being said, there are open source models that I literally can run on my cheap little laptop right in front of me. A 9 billion parameter model, like I said, I think I can run 4 of them simultaneously on my MacBook. The benefit of that, Sean, is that if I can download the weights are parameters, okay? If I can download these weights like a llama model and run it directly onto my laptop, and then prompt that LLM to query information, I'm still it is entirely under my control. So I'm not worried about sending sensitive customer information up to the nebulous cloud or to the AI provider. Now, that being said, a lot of those AI providers, they do actually have protections against your data within their security policies. I will leave it to everyone else to read through those with your lawyers to make sure that your customers' data is secure. But don't let that be a barrier to getting into AI. There are smaller models that you can control that can run on machines you own, and they can accomplish magical tasks. So
awesome. Thank you,
you guys
Paul.
want to
And just to get through the
Q&A,
I know we're coming up at time in about 8 minutes. So here's one. Richard asks, Robert, would you recommend any specific resources or videos to recreate this? I think talking during your presentation, Robert, regarding the flashcards or the AI agents, what would you recommend? What has helped you?
I mean, I've learned so much by just watching YouTube videos on topic of N8N, having some good foundation in whatever API that you want to engage. Acumatica has got extensive APIs at the end of things, so like you can easily tie in Acumatica stuff into this and create a tool that will like, hey, go create a customer record based on this input from a chat bot sort of stuff. I personally bought into a course on the topic of N8N. I certainly want to excel at all of this stuff. I could give some recommendations. AI Foundations is the guy that I'm doing some training with, and he's got a plethora of stuff that's out on YouTube. There's all sorts of stuff on YouTube about it. Creating an audio file, it's just the type of node that's in there, and it's pretty easy. What I want to do is I want to try to see if I could pitch getting another coffee and code session where I go and I build this from scratch with you guys. Just walk through how easy it is to work with this product.
Gotcha. Thank you, Robert. Maybe this question is more directed at Marco, since you showed off like a custom solution through that mobile application there. Has Acumatica provided like a set of AI methods, tools, maybe best practices for AI development platforms? Or if you were to make one, what would that certification look like? Do you think it would be similar to what Acumatica does now with like the custom solutions for developers?
Well, it's a good question. Actually, I will invite everyone to look into the Acumatica roadmap for AI. There's it's been discussed and announced. There's the AI Studio and all the different tools that Acumatica is working and building within the framework. So I would stay informed of what's available to leverage that. But besides what Acumatica is building within the platform, if you want to start building out something right now with what's available, there's a lot of tools if you look to leverage existing tools like the Acumatica API, right? So you can build an agent that uses the API. Basically, we just need to build this, input the schema of the calls, so it knows how to translate whatever you ask it into the API calls, and have either just an API tool that makes that call in your framework, or another agent that makes the call that is connected to be to call API endpoints. For example, the agent that I showed, because it's thought of as a tool for end customers, it uses the API on a sandbox environment where it can only access specific information for that specific customer, and it uses the API to get that information. So that's like a really easy starting point. Use the existing REST APIs, but obviously we can use other Acumatica tools like webhooks to build something more complex within Acumatica as a customization project, and connect that to our AI tool to do something specific that you need.
Awesome. Thank you, Marco. Let's kind of build off that question a little bit then. Doug asks, how do you proceed to solve these data conversion problems? I guess this is a question for all three of you. If you were to make a customization Acumatica and you wanted to involve AI as part of the planning, the troubleshooting, what does that look like for one of you? Like, how has it helped you kind of, organize your thoughts, or like go through the development process? Do you use AI right now to help develop customizations? Anybody can answer.
You just go into a divide and conquer sort of approach. So if it's like writing a method. I mean, you want to get in there, have a short and sweet AI agent that just does one thing really well, and then you just do the coding to send that stuff through a method call. So everything that we showed you, you can engage programmatically. You don't need N8N to as an intercept for any of the stuff. You can use it. It's still there as a tool. There's ways that you could tie in like a webhook and send something to a webhook, have it do something, return some data back. You would do that in the same way that you would write up a custom endpoint. Or you can just get into the nitty-gritties of things and just use the software development kit that comes along with these tools.
Awesome. Thank you, Robert.
I highly recommend Cursor. If you're a coder, I love using Cursor. Cursor, if you're not familiar, it is an extension to VS Code. So it's just an IDE in which you are typing code in. But there's AI agents running in the back that can help you write the code. And it's interesting because within the tool, you can effectively tell those AI agents how much help you want, whether you want something like as simple as Copilot, if you're a coder and you've experienced Copilot, where it tries to recommend finishing the line that you're writing. You can ask it a request on a single file, or you can tell it to go through your entire repository. And it really all has to do with how much control you're handing over to this AI. The question that gets asked a lot is these AIs, again, they are like savants. They are incredibly knowledgeable about so many tasks, but also they can screw up and they can say strawberry has 2 R's in it. It's a very simple task that any human would not mess up. Mm-hmm. So it really has to do with how short of a leash are you going to give these AIs to act on your behalf. But actually, Vlad, are you asking about Doug Potter's question about data conversion?
Yeah, that works too. Yeah.
I would honestly focus on data conversion before creating import scenarios. Acumatica's import scenario, I think, is robust. And one way that we've handled that with one of my clients is, frankly, just having a large language model format the data into an Excel sheet. Large language models know how to do that really, really well. And so effectively, you're just creating the data provider that's going to go into your import scenario. And the nice part about that is you can have fuzzy records go through a large language model and create an Excel file. And if you can even prompt a large language model. I got this one from Clouvir. I love that idea that if you are ever unsure, add not found or add unknown, because then when it's imported into Acumatica, you can have one of your customer service team go and check the records.
Yeah,
Awesome.
actually, I was going to say something like that. Going back to start simple, I would just pick the thing that's more complex in your process. If it's duplicates or fuzzy or incomplete data, just have the LLM look at that and output into a useful and known format like CSV or Excel, and then go from there. And don't try to build everything in LLM. Just start using it for exactly what you need.
You also have the ability to just create JSON records as well, a long list of JSON records, and just feed that directly to integration point, because that's something that it does exceptionally well as well. And that's where you want to do like end-shot type prompting, where you get a consistent result, where you need that consistent result, and format. This is exactly how I need the results to be structured. And then you just feed that into an HTTP request, and Bob's your uncle. The data's where it needs to go.
Awesome. Thanks, everybody. We are at the top of the hour. I just want to do a quick reminder. This is being recorded. It will be shared on the community page after it's been edited. We put some little bookmarks for all the certain presentations. We also working on a blog post to post on the website just to get some follow-up information, do a bit more of a deep dive on some of these topics presented. And we have a feedback form being shared. We love feedback. It helps us improve these webinars. One lucky winner will get some swag. And again, I do want to thank Paul, Robert, and Marco for coming on today as some all-star developers to show how they're using AI in their day-to-day, how you can kind of utilize that in the Acumatica platform and other technology improvements that we're making. So again, thank you, everybody, for attending. Really appreciate it.
Thank you. Bye.
Yeah, it's a pleasure.
Thanks.